Another measurement we learned in this chapter is volume. How can you calculate the volume of an object? So volume can be calculated from the dimension. It's calculated by multiplying the length times the width times the thickness. Now all the three measurements that of the length, the width, and the thickness must be in the same unit. This is where when the unit conversion is needed, and that's why you learn early in this lecture and last week about unit conversion. Let's look at an example. If an object measures 4 centimeters by 2 centimeters by 1 centimeter, the volume is a centimeter cube or 8 cubic centimeters. You see here in this box, the thickness 1 centimeter, the width 2 centimeter, and the length 4 centimeter. They all have the same unit, that is centimeter. So like I said in the previous slide, they must have the same unit. So when you multiply a centimeter to centimeter to centimeter, you got a cubic centimeter. Liter is used as the basic unit of volume in the metric system, as we learned earlier today. Recall that 1 liter is defined as the volume is occupied by a cube that is 10 centimeters on each side. So there can be your thickness, the length, and the width. Therefore, 1 liter is equal to 1,000 cubic centimeter. So you have the unit equation for volume at 1,000 cubic centimeter equals to 1 liter equals to 1,000 milliliter. So therefore 1 cubic centimeter equal to 1 milliliter. This is your new unit equation. Let's look at one example of cubic liquid volume conversion. An automobile engine displays a volume of 498 centimeter cube or cubic centimeter in each cylinder. What is the displacement of a cylinder in cubic inches? So now you convert centimeter cubed to inch cube or cubic inches. So you want the final unit in cubic inches, and you have the given unit is cubic centimeter. And we're going to use the unit equation. 1 inch equals 2.54 centimeter 3 times. Okay, so you start with what is given to you. You're given 498 cubic centimeter, and then you use the unit factor inch and centimeter and 3 times. So you see centimeter, cubic centimeter, it means 3 of the centimeter multiplied together, remember in the previous slide. So the 3 of this, so 3 cancel 3 times 1, 2, and 3. That gives you the final unit is inch, but multiply 3 times, inch multiplied by inch multiplied inch, that gives you cubic inches. This is how you set up a cubic liquid volume conversion. Volume can be calculated by displacement. Specifically for the solid that have irregular shape, its volume cannot be determined by the measuring its dimension like we did with the cube or the box, right? But you can determine its volume indirectly by measuring the amount of water it displays. This technique is called volume by displacement. Now, volume by displacement can also be used to determine the volume of a gas as long as gas is not soluble in water. And we talk about why the gas is not soluble in water. First, how you calculate a solid volume using the displacement method. For example, you want to measure the volume of an irregularly shaped piece of jade. You see, this is a picture of a piece of J, it doesn't have a regular shape. So what you do is you fill a volumetric flask with water and then measure volume of the water. For example, in this case, I fill up this volumetric flask with 50 ml of water. Then I add the J and measure the difference in volume. So put the J in, then the water level rise to 60.5 ml. So the difference in volume of this volumetric flask after I add the J symbol and before I add the J symbol is the difference between the two volumes, right? So that is 10.5 milliliter. This is the volume of the J symbol, and that's why we call it water displacement method. Now you also can use this displacement method for to calculate the volume of a gas. So you want to measure the volume of gas given up in a chemical reaction. You can display the water in the flask into a beaker. So the volume of the water displayed is equal to the volume of a gas. So you see when the gas is formed in this test tube, if it would burst into this the flask, some of the water will got pushed out, and it's go into this beaker. So the change in the volume of water in this beaker is the volume of the gas that display water in this flask. So that's how you determine the volume of the gas from this tube. The next concept we learn about the measurement is the density concept. Density of an object is a measure of its concentration of mass. So density is defined as the mass of an object divided by the volume of an object. A mass divided by the volume that gives you the density of an object. Density is expressed in many units. Usually it's gram per milliliter for liquids, a gram per cubic centimeter for a solid, and gram per liter for gases. How you can calculate the density? Let's look at an example of calculating density. What is the density of a platinum nugget that has a mass of 224.5 grams and a volume of 10.0 cubic centimeter? Remember, we say density equal mass divided by volume. You should put it in mass at 224.50 grams and the volume of 10.0 cubic centimeter. If you put these two numbers into a calculator, you got the answer 22.5. It had 3 significant digits, the same as the volume, because volume had the least number of significant digits. Now, just like the percentage, density can be expressed as a unit factor. Then you can use it for conversion between the mass and the volume. For example, an automobile battery contains 1,275 milliliter of acid. If the density of a battery acid is 1.84 gram per ml, how many grams of acid are in an automobile battery? Now you have the volume, you want the mass. So using the density formula, density equal mass divided by volume, you can find mass. So mass equal density multiplied by volume. So you put this number into the calculator, it gives you 2,350 grams. See, the unit of volume cancel out, the remaining unit is gram. Now this number again had 3 significant digits because the mass only had 3 significant digits. Next, we will learn about the temperature measurement. Temperature is a measurement, is measure the average kinetic energy of individual particles in motion. So there are three temperature scale of Fahrenheit, Celsius, and Kelvin. Kelvin is the absolute temperature scale. So in the temperature scale, the water freeze for the Fahrenheit scale, the water freezes at 32 degree and boils at 212 degree. On the Celsius scale, water freezes at 0 degrees, but it boils at 100 degrees. These are the reference points for the Celsius scale. In the Kelvin scale, the water freezes at 273 Kelvin and boils at 373 Kelvin on the Kelvin scale. Now, just like other unit, the temperature unit can be converted from one unit to the other. The relationship between the Fahrenheit and Celsius temperature scale is a linear. So therefore, this relationship can be represented in a standard format of an equation for a straight line. So this equation below shows you how to convert a Celsius degree to a Fahrenheit degree. So you just need to memorize the unit equation for converting one temperature in Celsius to a temperature in Fahrenheit. Now, instead of convert the Celsius degree to Fahrenheit degrees, you also can convert the Fahrenheit degree to Celsius degree using this equation. How to convert Celsius to Kelvin? You just add 273. So Kelvin degree equals Celsius degree plus 273. That gives you Kelvin degree. So K stands for Kelvin. Next, and also the last concept we learned in the chapter is the heat concept. The heat concept is a measure of total energy. Temperature measures the average energy of particle in a system. So heat is often expressed in terms of joules or abbreviation J, or calories, or CAL. Now this picture will show you, give you a better idea of the of how temperature differs from heat. So you see both the bigger big globes have the same temperature, 100 degrees Celsius, so both at 100 degrees. However, the beaker on the right has tried the amount of heat because it had tried the amount of water. The volume of this beaker on the right, or B, is 1000 milliliter, whereas the volume of the water in the beaker in figure A is only 500, so it got tried the amount of heat. That is general heat. How about the specific heat? The specific heat of a substance is the amount of heat required to raise the temperature of 1 gram substance to 1 degree Celsius. It can be expressed in a unit calorie per gram or per degree Celsius. So the larger the specific heat, the more heat it required to raise the temperature of a substance. I give you some example of specific heat. For water, it's 4.184 joule per gram per Celsius degree. That is mean it requires 4.184 joule of heat to raise the temperature of 1 gram of water for 1 degree Celsius. Similar for iron, it requires 0.450 joule of gram of heat to raise temperature of 1 gram of iron for 1 degree Celsius. Now for aluminum, the specific heat is 0.890. It's more than iron. That means it requires more heat to raise the temperature for the same mass for the same degree, like 1 degree Celsius. The question for you for application specific heat: if I want to make a pot using iron and aluminum, which metal should I use for the pot? Iron or aluminum? Which metal should I use for the handle of this pot, iron or aluminum? So I leave it to you, and you tell me what the answer is when I meet you in the class next time.